This video is looking at solving radical equations. Okay, so this is, I know it's not quite in the same order as what the book goes, but I figured after looking at simplifying radicals, made logical sense to now let's go solve with radicals. So, a radical equation is simply an equation with a variable under the radical. Okay, so it's an equation with a variable under the radical. So that could be square roots, it could be cube roots, fourth roots. It doesn't really matter what the radical is or what the root is. If there's a variable underneath it and an equal sign, we can solve for that variable. So my goal, we're going to go through basically 4 steps. We're going to try to isolate the radical on one side, and then we're going to undo the radical by raising to a power, and then we'll solve for x. The big thing that I have to remember, though, is once I find my x values, is that I need to plug them back into the original equation that was given to make sure they work. So, because if you remember back when we did absolute value, we had things called extraneous solutions, and that was a solution that once I plugged it back into the original, it didn't actually work. So we need to check for extraneous solutions. Okay, so for this first one, okay, the radical is already isolated. So since it's a cube root, in order to undo it, I'm going to raise it to the third power. Now if I do that on one side, I got to do it onto the other. Now I raise to the third power because if I think of this in terms of stuff, so I'm just going to put stuff to the 1/3 power. Okay, so I've got 2x plus 7 raised to the 1/3 power. So if I raise that to a 3/1, using my rules, okay, my exponent rules, when I have a power raised to a power, I multiply these. So I'd have 1/3 times 3/1, which is 1. But if I do that on one side, I have to do it on the other. So that's going to give me 2x plus 7 is equal to 3 cubed, which is 27. So now solving for x, I'm going to subtract 7 from both sides. And that's going to leave me with 2x equals 20. And then I'm going to divide both sides by 2 to get x equals 10. So when I go to do my check, I'm going to plug that back into the original. So I'm looking for, is the cube root of 2 times 10 plus 7 equal to 3? All right, so 2 times 10 is 20, plus 7 is 27. Cube root of 27 is in fact 3, so it works. So x equals 10 is my solution. The other big thing to remember with these two is when you do when we work with the odds, if I were taking the cube root of both sides, we would get our answer. If I had an even root, if I did take the square root, say, of both sides, I'd have to do a plus or minus. But since I am raising to a power like 3 or 2 or 5, we don't need pluses or minuses because we're not taking a root of both sides. So just keep that in mind. So when we're solving here, we don't need pluses and minuses like we did when we were taking the root. Okay, so let's look at the next example. So it wants us to solve 5 times the square root of 3 minus x plus 2 equals 22. So that's this problem right here. So I need to isolate the root first. So I'm going to do reverse order of operations. Okay, so that means I'm going to start with addition and subtraction first. So I'm going to get rid of the plus 2. So I've got 5 times the square root of 3 minus x. 22 minus 2 gives me 20. Okay, I've gotten rid of that. So now I'm going to get rid of multiplication division. So I'm going to divide both sides by 5. So it's going to give me square root of 3 minus x is equal to 4. From here, I am going to raise, since this is a square root, I'm going to then square to undo it. So I'm going to do that to both sides. So now that gives me 3 minus x is equal to 16. Start getting x by itself. And then I divide by -1. So I get x equals -13. So now I'm going to plug this back in to make sure that it works or doesn't work. Okay, so I got to figure that out. So basically my question is, does plugging in -13 into the original work? So I've got 5 times 3 minus -13 plus 2. Does that equal 22? So I've got 3 plus 13, that's 16. Square root of 16 is 4. 5 times 4 is 20. Plus 2 is 22. It does work. Okay, so x equals -13 is my solution. Let's look at one that has no solution. All right, so again, I'm going to isolate my square root by undoing addition subtraction first. So I'm going to subtract the 6. So that gives me 7 times the square root of 5x minus 4. If I subtract 6 from both sides, that's going to give me -5 on this side. Divide both sides, because now I'm on to undoing multiplication division. Divide both sides by 7. That's a little ugly, but so we get -5 over 7. And now I need to square both sides. So that means I need to square this whole fraction. All right, using our rules for raising a fraction to power means I need to give the 2 to both the -5 and the 7. So I've got 5x minus 4 since the square root cancels out. -5 squared is 25. 7 squared is 49. When I add 4 over 1 to both sides, if I force it to be over 49, that means you are going to be adding 196 over 49 to both sides. Okay, so that's going to give me 5x is equal to 25 over 49 plus 196. So that's 221 over 49. And if I divide by 5, I get 221 over 245. Yucky, yucky number. Now what you're going to find when we plug this back in, okay, so let me change colors here again. When I plug this back in, I've got 7 times the square root of 221 over 49. Now it's supposed to be minus 4, but I'm going to make that common denominator. Does that equal 1? 221 minus 1. 221 over 49 minus 196 over 49 is going to give me that 25 over 49 back. So I basically have 7 times the square root of 25 over the square root of 49 plus 6. Does that equal 1? So I have 7 times 5/7, which is just 5. Okay, so this seven times, so these cancel, so I get 5 plus 6, which is 11, and that does not equal 1. So this one has no solution. All right, so let's look at example number 3. Okay, this one's slightly more challenging. So notice I've got a 3 minus x and a square root again. Again, these can be any root. It could be to the 3rd power, it could be the 5th power. So at this point, I have isolated the radical, so I need to just square both sides to undo the square root, which means I got to square this whole quantity here. So that means 3 minus x times 3 minus x. So I'm going to go ahead and do that. 3 minus x, that gives me 9, -3x, -3x, and positive x squared. So I've got, when I square both sides, 2x minus 6 is equal to x squared minus 6x plus 9. And I'm going to, in order to solve something with x squared, it has to be equal to 0. So I'm going to move all of this stuff over to the other side. So I'm going to subtract the 2x, and I'm going to add the 6. So I've got x squared, so -6x minus the 2x gives me -8x, and 9 plus 6 gives me plus 15. So if you take a second and factor, that means I need what multiplies to 15 and adds to -8. That's what, -3 and -5. So I've got x squared, I've got 15, I've got -5x, -3x. Okay, so that's going to be x minus 5 and x minus 3. So I get x equals 5 and 3. Now I need to plug both of those back into the original. Okay, so does the square root of 2 times 5 minus 6 equal 3 minus 5? So I have 10 minus 6 is 4. Square root of 4 is 2. 3 minus 5 is -2. So 2 does not equal -2, so x equals 5 is not a solution. If I check the other one, okay, if I check 3, is 2 times 3 minus 6 equal to 3 minus 3. I have 6 minus 6, which is 0. The square root of 0 is 0, and 3 minus 3 is 0. So x equals 3 is my solution. All right, so you're going to try example 3, but my one comment to you is to first move this +1 over to the other side to make it look like the one we just did. So you're going to make it, actually let's change the color. So you're going to make it the square root of 3x minus 5 equals x minus 1. So it looks just like the one we just did, and then go ahead and solve. All right, so let's go one hair, again, deeper, a little more